And on the top of the bed are a series of cracks that make little polygons, most of which are rectangles. And we call these joints. These particular joints are structural joints. A joint is a crack in the rock on which there's been no movement. So there's joints, which is, well, I guess you could start with fractures. There's fractures, and then there's joint is one type of fracture, and faults is another kind of fracture. A joint is a fracture with no movement. A fault is a fracture with movement. We're going to see both. This is a joint. So it's a fracture in the rock along which no movements occurred, not vertical or horizontal or anything. But it's the beginning of what an aquifer is. If water continues to flow along these little cracks, remember the water's slightly acidic, this dissolves in weak acids, it'll begin forming little troughs, little canal-like things. And what you want to do is turn around and look at all these little caves in the wall. You notice all those little caves are in the same formation. They're all over here, just little holes in the wall. And those are fractures, joints, which have expanded as water flowed through them to become conduits. And that conduit is what becomes the aquifer. So if we tried to get water out of here, we'd get some, but it would be not very much and not very fast. So it's not a good aquifer. What you want for an aquifer is something that'll give you tens or hundreds of thousands of gallons per hour. Wow. This particular rock would give you maybe a gallon a day. That's not going to take care of a city like San Antonio, which uses the aquifer similar to this. So remember those little tunnels, and you can look all the way down the gorge at that layer, and those tunnels are there. So there's something in that particular rock that allows it to dissolve into those little caves.